Hare Krishna. This is my 8th video, and again I am continuing the inverse trigonometric function part 5, isn't it? So I am continuing the inverse trigonometric function, the derivative of a inverse trigonometric function. That is the part 5, isn't it? In the last session we have taken the problem on what here? Cos 2 theta. How many formulas of a cos 2 theta? First, cos square theta minus sin square theta. Second, 1 minus 2 sin square theta. Third, 2 cos square theta minus 1. The fourth, 1 minus tan square theta divided by 1 plus tan square theta. Isn't it? So we have taken the problem on the 3 formulas. Right? Now the last formula, that is cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta, 1 minus tan square theta divided by 1 plus tan square theta. Again, one type it is remain on that formula. So let us consider again the problem. Cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. See, the different type of again problem I will take on this formula, cos inverse e raised to minus x, e raised to x divided by e raised to minus x plus e raised to x. Second one, cos inverse a raised to minus x minus a raised to x divided by a raised to minus x plus a raised to x. The third one, sin inverse 2 raised to minus x minus 2 raised to x divided by 2 raised to minus x plus 2 raised to x. Right? See, little bit different, isn't it? Suppose I consider the one cos inverse e raised to minus x minus e raised to x divided by e raised to minus x plus e raised to x. How will you decide? First, what you have to do, you have to convert the negative index into positive. Right? First you have to convert whatever the negative index into positive. If a raised to minus 1, how will you convert in the positive form? Taking in the denominator. A to the power minus 2 you can write as a 1 upon a square. A to the power minus 3 you can write as a 1 upon a cube. In the same way, here also cos inverse 1 upon e raised to x minus e raised to x divided by 1 upon e raised to x plus e raised to x. Right? Again, by cross multiplication, 1 minus e raised to x, e raised to x, you have got the e raised to x whole square divided by e raised to x. Again, 1 plus e raised to x, e raised to x, e raised to x whole square divided by e raised to x. Right? Again, e raised to x get cancelled. What is remain? Y is equal to cos inverse 1 minus e raised to x whole square divided by 1 plus e raised to x whole square. Now this problem, it is converted, that we have done already in the last session, isn't it? So here, what you have to do? Again you have to put e raised to x is equal to tan theta. Therefore y is equal to cos inverse 1 minus tan square theta divided by 1 plus tan square theta. Right? Again, this is the formula of cos inverse. Again, cos 2 theta. Cos inverse cos get cancelled. What is remain? 2 theta. Again 2. What is theta? Tan inverse of e raised to x. Therefore, what is the result here? The differentiation, that is dy by dx, to remain as it is. Again apply the chain rule. Here you have to substitute u. Tan inverse u, the derivative of a tan inverse u, 1 upon 1 plus u square means ex whole square means e raised to 2x. And what is the derivative of e raised to x? E raised to x, right? Now the remaining problem you can do yourself. The same here, that is only in place of e I have given a, and only in place of e I have given 2. The same procedure you have to follow. Since there is a sin inverse and the formula it is of a cos 2x, cos 2 theta, sorry. Here you will get only the minus sign. इथे फक्त तुम्हाला काय मिळेल, मायनस साईन मिळेल. द रिमेनिंग यू कॅन डू युअर सेल्फ, राईट. सो आय एम गोइंग टू टेक द प्रॉब्लेम ऑन tan 2 theta. What is the formula of a tan 2 theta? See here, tan 2 theta, it is equal to 2 tan theta divided by 1 minus tan square theta, right? See, here the first one, y is equal to tan inverse 2x divided by 1 minus x square. Second one, tan inverse 8x 1 minus 4x square. Third one, tan inverse, you can write here 2 e raised to 4x 1 minus e raised to 8x. Fourth one, y is equal to tan inverse 2 log x divided by 1 minus log x whole square. And the fifth one, y is equal to tan inverse sec 3x 1 minus sec square 3x. These are the 5 problems. Again I will take C here. The first one, tan inverse 2x divided by 1 minus x square. Now when you see this formula, tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. This term should we want in this bracket. Therefore obviously you can substitute x is equal to tan theta. Therefore y is equal to tan inverse 2 tan theta divided by 1 minus tan square theta. And again you know the formula of a tan 2 theta, isn't it? Tan inverse tan get cancelled. Here what is remain? 2 theta. Again y is equal to 2. What is theta here? The theta, it is nothing but tan inverse of x, isn't it? Therefore 2 tan inverse of x. What is the derivative? dy by dx. 2 remain as it is. The derivative of a tan inverse x, that is 1 upon 1 plus x square, isn't it? So this is about the problem which is depending upon what here? The formula tan 2 theta. What is the formula of a tan 2 theta? 2 tan theta divided by 1 minus tan square theta, right? The direct result, the derivative of this 2x, that is equal to 2, and here in the denominator we want only the plus signs here, 1 plus x square. Have you got this? See here you have got. Again the what is the derivative of 8x? That is 8, and in the denominator you have to write 4x square. Here what is the derivative? 2 remain as it is, e raised to 4x. The derivative of 4x, that is 4, and here 1 plus e raised to 8x. These are the result, isn't it? Again 2 remain as it is. The derivative of a log x, that is 1 by x, and the remaining term here, that is the denominator 1 plus log x whole square. Right? This is the shortcut, isn't it? Now again, what is the derivative of a sec 3x here? 2. 2 sec 3x, again 2 remain as it is. Sec 3x, tan 3x, again 3x 3, and divided by 1 plus sec square 3x. The directly short tricks, right? Here you can find out the answer like this, short tricks here. Again I will take the one more problem. See, y is equal to tan inverse 8x divided by 1 minus 4x square. Again by the formula, what do you want? Here 2 you want strictly. When you take 2 from 8, what is remain here? 4x. When you take 2 from 8, you will get 4x, because 4 2s are 8, and here again 4x whole square. Here 4x whole square means here you want 16x square. Sorry, here you want, that is in this problem. See the second one is here like this, that is 8x and divided by 1 minus 16x square, right? So this is the second one, and the result is the derivative of 8x, that is 8, and here only you have to change the sign, right? Now here you want 2 compulsory. Therefore, when you take 2 from it, again what is remain here? 2, and into what here? 4x. And the 16x square you can write as a 4x whole square. Right? Therefore, here you can substitute 4x is equal to tan theta, y is equal to tan inverse 2 tan theta divided by 1 minus tan square theta. Again, this is the formula of tan 2 theta, right? Tan inverse tan get cancelled. What is remain? 2 theta, isn't it? Therefore, 2. What is theta here? The theta, it is nothing but tan inverse of 4x, right? Therefore, in place of theta, you can substitute tan inverse of 4x. Therefore, dy by dx, it is nothing but 2 tan inverse u, that is nothing but 1 upon 1 plus u square, means 4x whole square, that is 16x square, and the derivative of a 4x, that is 4. Therefore, 4 to the 8 divided by 1 plus 16x square. Have you got this? This is the second one, right? Now I will take the fourth one, and the remaining you can do yourself. See, the fourth one, y is equal to tan inverse 2 log x divided by 1 minus log x whole square. Again, very simple. Where you have to substitute? In place of log x, you have to substitute tan theta, so that your problem get into standard formula of the tan 2 theta, isn't it? Therefore, here put log x is equal to tan theta. Therefore, theta is equal to tan inverse of log x, right? Now here again, y is equal to tan inverse 2 log x means tan theta divided by 1 minus tan square theta, right? Now, this is the formula of what? Tan 2 theta. Again, tan inverse tan get cancel. What is remain? 2 theta. Again 2. What is theta? Tan inverse of log x. Right? Now apply the chain rule for finding the derivative. 2 remain as it is. Here you can substitute u. What is the derivative of a tan inverse u? 1 upon 1 plus u square, means log x whole square. And the derivative of a log x, that is equal to 1 by x. So here we have finished the problem on what here? Yesterday we have finished the problem on sin 2 theta, cos 2 theta, 3 formulas, and here today I have completed, that is the tan 2 theta, that is equal to 2 tan theta divided by 1 minus tan square theta. Now the turn is of a triple angle formulas. Again there are the problems on what here? Triple angle formulas, that is sin 3 theta, cos 3 theta and tan 3 theta. So I am continuing again the inverse trigonometric function and the problem depending upon the triple angle formulas, right? So see the triple angle formulas, triple angle formulas, right? Now sin 3 theta. See what is the formula of a sin 3 theta? 3 sin theta minus 4 sin cube theta. 4 sin cube theta. Now I am going to take the problem on this formula. See, here the first one, y is equal to sin inverse 3x minus 4x cube, right? Second one, y is equal to cos inverse, again 3 root x 4x root x. Again third, y is equal to sin inverse 6x, here 32x cube, right? Again fourth one, y is equal to cos inverse 3 e raised to x minus 4 e raised to 3x. And the fifth one, sin inverse 3 log x minus 4 log x whole cube, right? Again the 5 problem we have to take. Very simple again. The same procedure you have to follow, but once you have got the idea, you can do the any problem in the exercise by your own. स्वतः तुम्ही ते प्रॉब्लेम करू शकता, स्वतः त्या प्रॉब्लेमशी डील करू शकता, राईट. We have to study the concept in such a way that so that you can yourself deal with the problem, you can yourself solve the problem, isn't it? That capacity you must have that capacity so that you can do the problem yourself, right? For that purpose I am going to take the variety of a problems. So the first one, that is again y is equal to sine inverse 3x minus 4x cube. See, if you see this formula, sin 3 theta is equal to 3 sin theta minus 4 sin cube theta, right? Means in bracket we want this formula so that sin inverse sin get cancelled, and whatever the something it is remain, you can find out the derivative. Obviously by seeing this you can substitute what here in place of x, you can substitute sin theta. Therefore theta is equal to sine inverse of x, right? Therefore y is equal to sine inverse 3 sin theta minus 4 sin cube theta, right? Again y is equal to sine inverse, this is the formula of sin 3 theta. Sine inverse sin get cancel, what is remain 3 theta. Again y is equal to 3. What is theta? Sine inverse of x, right? Therefore dy by dx, it is nothing but 3, remain as it is. The derivative of a sine inverse x, that is 1 upon root of 1 minus x square, right? So this is about the sine 3 theta, the problem depending upon the sine 3 theta. Again if you observe the second one, see here the second one, see y is equal to cos inverse 3 root x and 4 x root x, right? Now see, what can you do? This is cos inverse, again this is root x, and this x root x you can write as a root x whole cube, right? X root x you can write as a root x whole cube, because root x whole cube means what here? Root x into root x into root x, root x into root x, x, and here root x. Therefore root x whole cube, it is nothing but what here? X into root x. Therefore in place of x root x you can substitute root x whole cube. Now obviously where you can substitute, you can put root x is equal to what here? Sin theta. Therefore theta is equal to sine inverse of root x. Therefore y is equal to cos inverse 3 sin theta minus 4 sin cube theta, right? Again y is equal to here cos inverse, this is the formula of sin 3 theta. Again the problem is there is a cos inverse and in bracket sin. What you have to do? Again you have to convert this sign in the form of a cos by taking the help of a pi by 2. Y is equal to cos inverse, that is cos of pi by 2 minus 3 theta, right? So that cos inverse get cancelled, what is remain? Pi by 2 minus 3, and theta it is nothing but sine inverse of root x. Therefore what is the derivative? The derivative of a pi by 2 is 0, minus 3 remain as it is. Here again you have to apply the chain rule. The derivative of a sine inverse u, root x you have to substitute as a u, 1 upon root of 1 minus u square, means root x square means x. And what is the derivative of a root x? 1 upon 2 root x, right? This is about the second one, isn't it? So here I have changed only this x, I have changed. Sometimes I have write e raised to x, sometimes I have write root x, and in that way I have changed the problem, isn't it? I have changed this, the term in the bracket, right? But here you have to make the substitution very carefully, isn't it? Now again suppose I take the third one, sine inverse 6x minus 32x cube, see, right? Now again what do you want? Which term we want? Again 3 you compulsory want. What is remain? When you take 3 from 6x, you have got 2x, isn't it? Here also 4 you want compulsory. When you divide it with 4, you have got what here? 8, isn't it? Because 8 4s are 32, right? 8 4s are 32. Therefore, what is remain here? That is 8. And 8x cube you can write as a 2x whole cube, right? Now your problem, it is in a standard formula. Now obviously where you can substitute 2x is equal to sine theta, right? Therefore here you have to substitute, see, 2x is equal to sine theta. Therefore theta is equal to sine inverse of 2x. Therefore y is equal to sine inverse 3 sine theta minus 4 sine cube theta, right? Y is equal to sine inverse, again 3 sine theta minus 4 sine cube theta. This is the formula of sine 3 theta. Sine inverse sine get cancel. What is remain? 3 theta, right? Again y is equal to 3. What is theta? Sine inverse of 2x. Apply the chain rule to find out the derivative. 3. Again you have to substitute u. Sine inverse u derivative 1 upon root of 1 minus u square means 4x square. And what is the derivative of a 2x? That is 2. Therefore 3 2 is 6. 6 divided by root of 1 minus 4x square. Right? This is about the third one. Now here, in place of e raised to x, you can substitute sine theta, and in place of log x, you can substitute sine theta. When you substitute e raised to x is equal to sine theta, what is remain? Theta is equal to sine inverse of e raised to x. Now the direct result is, here you have got 3 theta, therefore y is equal to 3 sine inverse of e raised to x, isn't it? But here there is a cos inverse, right? Here there is a cos inverse, therefore here you have got, though it is the sine inverse e raised to x, but there is a cos inverse, therefore this sine 3 theta you have to convert in the form of a cos, and you will get the answer that is equal to what here? The sine inverse e raised to x 3 means 3 1 upon root of 1 minus, this is e raised to 2x, e raised to x derivative e raised to x, and here you have got only the minus sign. Only the minus sign is there, right? Because this is, we have taken as a cos inverse. Whenever you take the cos inverse, you have got the minus sign, isn't it? And when you take the sine inverse, you will get the positive result. So this is about the sine 3 theta. Now I am going to take cos 3 theta. See, what is the formula of a cos 3 theta? The formula of a cos 3 theta, that is equal to 4 cos cube theta minus 3 cos theta. Right? See, again the 5 problem. See, the first one, y is equal to cos inverse 4x cube minus 3x. Right? Second one, again sine inverse. Again here this is 8 4 32x cube, and here 6x. Right? Third one, cos inverse 4 log x whole cube minus 3 log x. Right? Again fourth one, y is equal to sine inverse 4 cot cube x minus 3 cot x, isn't it? And again fifth one, y is equal to cos inverse 4, you can write as a sine cube x minus 3 sin x. Right? In this way also you can take the problem. Now I will take the first one. See, first one, that is y is equal to cos inverse 4x cube minus 3x. Right? Now what you have to do? Again, to get this formula, in place of x, you have to substitute as a cos theta. Then and only then, you will get the formula of a cos 3 theta. Therefore, cos inverse cos get cancelled, and whatever the remain, you will get, you can find out the derivative of that function. Right? Therefore, put x is equal to cos theta. Therefore, theta is equal to cos inverse of x. Right? Again, y is equal to cos inverse 4 cos cube theta minus 3 cos theta. This is the formula of cos 3 theta. Right? Again, cos inverse cos get cancelled. What is remain? 3 theta. Y is equal to, again, 3 theta. What is theta? Cos inverse of x. Therefore, dy by dx. 3 remain as it is. Cos inverse x, the derivative of a cos inverse x, that is equal to minus 1 upon root of 1 minus x square, isn't it? Therefore, the result is, that is minus 3 divided by root of 1 minus x square, right? So, here you have got the result. See here again. The second, I will take the fourth one. Fourth one. In second, what you have to do? When you take 4 common from what here? 32. What is remain? 8. 8x cube. You can write as a 2x cube. Isn't it? And here when you take 3, what is remain? 2x. Right? 4. 2x cube minus 3. In place of 2x, you can substitute what here? Cos theta. Right? Therefore, I am going to take here the fourth one. Right? Fourth problem I will take. Fourth one. Y is equal to sine inverse 4 cot cube x minus 3 cot x. See. Now again, if you observe this, in place of cot x, see here, in place of cot x, you have to substitute cos theta. Therefore, theta is equal to cos inverse of cot x. Right? Cos inverse of cot x. Therefore, this problem becomes sine inverse, this is 4, and in place of cot cube x, you can substitute what here? Cos theta. Therefore, 4 cos cube theta minus 3 cos theta, that is sine inverse. Again, this is the formula of a cos 3 theta. But the problem is, there is a sine inverse, and in bracket, there is a cos. Again, cos, you can convert in the form of a sine by taking the help of a pi by 2. Sine inverse, you can write as a sine of pi by 2 minus 3 theta. Isn't it? Again, sine inverse sine get cancelled. Pi by 2 minus 3 theta. What is theta here? Cos inverse of cot x. Right? Again, dy by dx. The derivative of a pi by 2 0. Minus 3 remain as it is. Apply chain rule. Cos inverse u, in place of cot x, you have to substitute u. Therefore, what is the derivative of a cos inverse u? Minus 1 upon root of 1 minus u square means cot square x. And the ddx of cot x, again, this is minus minus plus, this 3. What is the derivative of a cot x? Minus cosec square x. Again here, you have got minus cosec square x and divided by root of 1 minus cot square x. Isn't it? This is the result. Right? So, here you have got the result, minus 3 into cosec square x divided by root of 1 minus cot square x. This is about the fourth problem. And the remaining, second, third and the fifth also you can do yourself. Isn't it? So, again the third formula, that is tan 3 theta. See, what is the formula of a tan 3 theta? 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Right? So, the problem, it is depending upon the third triple angle formula, that is tan 3 theta. What is the formula for tan 3 theta? 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Right? Again I will take the problem on this formula. See, here the first one, y is equal to tan inverse 3x minus x cube divided by 1 minus 3x square. Isn't it? Second one, y is equal to tan inverse, here again 9x 27x cube divided by 1 minus 27x square. Third one, y is equal to tan inverse, here that is 3 log x minus log x whole cube divided by 1 minus 3 log x whole square. Right? Here fourth one, y is equal to tan inverse, here again you can convert this problem in the form of a cot inverse, right, by taking the reciprocal of a angle. If there is a sine inverse, then you can convert in the form of a cosec inverse, right? Every problem, if there is a sine inverse, by taking the reciprocal you can convert in the form of a cosec inverse. Again you will get one more problem, isn't it? If there is a cos inverse, again you can convert in the form of a sec inverse by taking the reciprocal of angle, isn't it? Therefore, whenever you do the problem sine inverse, cos inverse, again you will get the two more problem by converting by into the cosec inverse, sec inverse by taking the reciprocal of angle. Means so many type of a problem you have got here, right? So the always you have to remember, if there is a cosec inverse, first try to convert in the form of a sine inverse. If there is a sec inverse, then first you have to convert in the form of a cos inverse. If there is a cot inverse, first you have to convert in the form of a tan inverse by taking the reciprocal of angle. Strictly you have to follow this rule, isn't it? Don't do the problem in that way only. If there is a sec inverse sec, change, first change, it is converted into the cos inverse, right? So in that way you can continue the problem. This is root x, this is x root x divided by 1 minus 3x. This is fourth one. And the fifth one again, y is equal to tan inverse 3a square x minus x cube divided by a cube, and here 3x square a, 3x square a, isn't it? Now let us take the first one. See, the first one, very simple again. Tan inverse 3x minus x cube divided by 1 minus 3x square. Obviously you have to substitute x is equal to tan theta, isn't it? So that you will get this formula of a tan 3 theta. X is equal to tan theta. Therefore, x theta is equal to tan inverse of x, right? Now y is equal to tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, right? Y is equal to tan inverse, again this is the formula of a tan 3 theta. Tan inverse tan get cancel. What is remain? Theta. Again y is equal to 3. What is theta? Tan inverse of x. Right? Therefore, dy by dx, it is equal to 3 remain as it is. What is the derivative of a tan inverse x? 1 upon 1 plus x square. Right? So, this is about the first one. Right? What you have to do according to this formula, you have to make the substitution and do the problem. But you have to identify whether this problem it is depend upon this formula by seeing the term of this bracket, right? So that you should know all the formulas, isn't it, in your mind. then and only then you can decide whether this problem, whether it is depend upon which formula, isn't it? So it's very important to remember the formulas, and by doing the problem, variety of a problem, you automatically know the formulas, right? No need to by heart the formulas, but the number of a problems when the number of a problems you do daily, you will get the result automatically, isn't it? So for the mathematics, the practice is very, very important. If you make the more and more practice, you will get the good results, isn't it? For the examination. Now y is equal to tan inverse 9x 27x cube divided by 1 minus 27x square. What can you do? Here you want strictly 3. Therefore, when you take 3 from 9, what is remain? 3x. Therefore, 3 into 3x, isn't it? 27x cube you can write as a 3x whole cube, right? Again 1 minus this 27x square you can write as a 27x square. Again you want 3 here, right? When you take 3 common from what here 27, what is remain? 9x square, and the 9x square you can write as a 3x whole square, right? In this way, you have to manage the problem according to the formula. Now where you can substitute, it's very easy. In place of 3x, you can substitute tan theta. Therefore, theta is equal to tan inverse of 3x, right? Therefore, y is equal to tan inverse. This is 3 remain as it is. In place of 3x, you can substitute tan theta. Again, 3x whole cube means tan cube theta divided by 1 minus 3. 3x whole square means tan square theta, right? Therefore, this is the formula of tan 3 theta. Again, tan inverse tan get cancelled. What is remain? Theta. And here 3. What is theta? Tan inverse of 3x. Therefore, the derivative, that is dy by dx, it is equal to 3 remain as it is. Again here you have to apply the chain rule. When you substitute u here, 3x is equal to u. What is the derivative of a tan inverse u? 1 upon 1 plus u square means 9x square. And the derivative of a 3x, that is 3. Therefore here you have got 9 divided by 1 plus 9x square. Right? This is about the second one. Right? Now, in place of log x, again you can put tan theta. Root x you can put tan theta. Now I will take this one. That is the fifth one. Right? See, the fifth problem. Fifth one. It is quite different. Y is equal to tan inverse. Every problem you can convert in the form of a cot inverse. Isn't it? In their book, they have given that is sec inverse, cosec inverse, but again I am going to tell, whenever there is a sec inverse, whenever there is a cosec inverse, whenever there is a cot inverse, you have to convert in the basic formulas. That is what here cot inverse converted into tan inverse, sec inverse converted into cos inverse, and cosec inverse converted into sin inverse by taking the reciprocal of angle while doing the problem in book, that is in the textbook. 3a square x, this is x cube divided by a cube minus 3 ax square. Right? Now again, if you observe this, can you imagine yourself? According to the formula, you have to imagine, isn't it? You have to think over. Now if you observe this, there one should be strictly there. And here what is the term? A cube. We don't want a cube, right? For that purpose, to get 1, what you have to do? You have to divide it to this by what here? A cube. But can you divide only one term? Therefore, divide both numerator and denominator by what here? A cube. Here therefore, you have to divide both numerator and denominator by what here? A cube. Therefore, y is equal to tan inverse. When you divide it with a cube, what will you get here? That is 3a square x divided by a cube. A square get cancelled. Here you have got 3 and 1a it is remained. Therefore, here you have got 3 into x by a. Right? When you divide it with a cube, x cube divided by a cube means x divided by a whole cube. When you divide it with a cube to a cube, you will get 1. And here, when you divided 3a x square divided by a cube, right, 1a get cancelled. Here you have got 3x square divided by a square means this you can write as a 3x by a whole square, right? Here you can write x by a whole square. Now your problem, it is in a standard formula. Now where you can substitute, it's quite easy now. X by a, it is equal to tan theta. Therefore, theta is equal to tan inverse of x by a. Right? Therefore here, y is equal to, when you substitute tan inverse, this is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Again, this is the formula of what? Tan 3 theta. Tan inverse tan get cancelled. What is remain here? 3 theta. Again 3 remain as it is. What is theta? Tan inverse of x by a. Right? Now you can differentiate. See here. dy by dx. 3 remain as it is. This is u. What is the derivative of a tan inverse u? 1 upon 1 plus u square means x square a square. And ddx of x by a. Right? Here I will write. This is dy by dx. It is equal to 3 divided by cross multiplication. A square plus x square divided by a square, and this a square come into numerator, therefore a square. This is a square plus x square, and what is the derivative of x by a? That is 1 by a. Here a get cancelled. Here you have got 3a divided by x square plus a square. Right? So this is about the problem, that is the fifth one, that is tan inverse 3a square x minus x cube divided by a cube minus 3x square a. Isn't it? So I have completed, that is sin 2 theta, tan 2 theta, cos 2 theta, sin 3 theta, cos 3 theta, tan 3 theta. Right? Now we have to do some unusual one. See what are the unusual problem here. Right? Now see, unusual. Suppose I take the problem like this. See, can you imagine or not? 1 minus x cube divided by 1 plus x cube. Second one, so I take tan inverse sec 4x plus tan 4x. Third one, I will take tan inverse sec 2x plus tan 2x whole square. The fourth I will take tan inverse cosec 3x minus cot 3x. Fifth I will take y is equal to tan inverse again root of 1 plus x square minus 1 divided by x. So many unusual one. Now in this session I will take only the 5 and the remaining one I will take in the next session, isn't it? Again there remains, that is the derivative of a trigonometric function, part 6. And in the part 6, we should complete the inverse trigonometric function, isn't it? So, I will take today in this session only the 5 unusual one. See, unusual one. The first one, y is equal to tan inverse root of 1 minus x cube divided by 1 plus x cube. Can you decide, if you observe all my video, can you decide where you have to substitute, means what you have to do? You can't imagine, isn't it? Therefore, it takes too much time. By practicing and practicing, then and only then your ideas get clear. Therefore, see here, you have to make the substitution in such a way that, so that the square term you will get in the square root, isn't it? अशा ठिकाणी सबस्टिट्यूशन करायचं किंवा असं सबस्टिट्यूशन करायचं की स्क्वेअर रूटमध्ये कुठली टर्म मिळाली पाहिजे, स्क्वेअर टर्म मिळाली पाहिजे. Right? Since there is a tan inverse, here also you want tan of something, isn't it? Therefore, what you have to actually substitute, so that you will get the square term in the square root. Right? तो क्या करना है, इसको कैसे substitute करना है, इसको ऐसे substitute करना है, so that you should get the square term, that is x square, cos square, tan square term you should get, isn't it? So that you can take out of the root, isn't it? Therefore, what you have to do, see here you have to put x cube is equal to cos theta, right? Therefore, here you have got tan inverse 1 minus cos theta. Again, theta is equal to what here? Cos inverse of x cube, right? Now 1 minus cos theta, 1 plus cos theta, and you know this is the evergreen formula. I have given the name for this formula, that is the evergreen formula in the right. Therefore, 1 minus cos theta you can write as a 2 sin square theta by 2, and 1 plus cos theta you can write as a 2 cos square theta by 2. 2 to get cancelled, again tan inverse the square root of sin square theta by 2 and cos square theta by 2, that is sin theta by 2, cos theta by 2, and here you have got y is equal to tan inverse tan theta by 2, right? Therefore, tan inverse tan get cancelled, theta by 2, again 1 by 2. What is theta? Cos inverse of x cube, right? dy by dx. 1 by 2 remain as it is. Cos inverse u. What is the derivative of a cos inverse u? Minus 1 upon root of 1 minus u square. Means what here? The square of a x cube, that is x to the power 6. And the derivative of a x cube, that is equal to 3x square. Therefore, the result is minus 3x square divided by 2 root of 1 minus x to the power 6. This is about the problem, and this is unusual. It is not depend upon the any particular formula, isn't it? Here you have to make the substitution, that is cos theta, so that you have got the square terms here, sin square theta, cos square theta. Then and only then you can take out of the root, isn't it? Now in the same way, the second. Now this problem and this problem, totally different, isn't it? So again, I will take the second one. See, every problem, it is different from each other. Now second one, y is equal to tan inverse sec 4x plus tan 4x. What can you do? Is there any formula? Sin 3 theta, cos 3 theta, tan 2 theta. Is there any formula? Can you imagine yourself here? Can you apply any formula? No. Then what can you do? In your hand only there is a conversion. You can convert only sec in the form of a cos and tan in the form of a sin by cos, isn't it? So what you have to do? Y is equal to tan inverse. In place of sec 4x, you can write as a 1 upon cos 4x. And in place of tan, you can write as a sin 4x divided by cos 4x. इतना तो कर ही सकते हैं. Now see, tan inverse. Since the denominator is same, directly add the numerator, that is 1 plus sin 4x divided by cos 4x, and such a type of a problem we have done already in the last video here. So again 1 plus sin 4x you can write as a, what is the formula? See here, you can write cos 2x plus sin 2x whole square. In place of this 1 plus sin 4x you can write as a cos 2x plus sin 2x whole square. And what is the formula of a cos 4x? What is the formula of a cos 2 theta? Cos square theta minus sin square theta. On the same ground, what is the formula of a cos 4x? Cos square 4x minus sin square 4x. Right? Therefore, again, you can make the factorization, that is a square minus b square. Right? Therefore, cos 2x plus sin 2x, numerator remain as it is. Here you can find the factor. A square minus b square means a minus b, a plus b. Right? Cos 4x plus sin 4x. Right? Now again, if you observe this, again one bracket get cancelled, isn't it? What is remain here? Y is equal to tan inverse cos 2x plus sin 2x divided by this is, you have to write as a 2x. So cos 4x, the formula, that is cos square 2x and sin square 2x. Very sorry. Here again 2x. Here this is 2x. This is 2x. Now one bracket get cancelled. What is remain here? That is cos 2x minus sin 2x. Now here, what you have to do? Divide by cos 2x. Divide by cos 2x. Now when you divide it with cos 2x, see what you have got here, that is tan inverse, here 1 plus tan 2x divided by 1 minus tan 2x. Right? Now you can use the formula. Here I write, see the solution of this problem. Here I write here. Now y is equal to tan inverse, here 1 plus tan 2x divided by 1 minus tan 2x. You can use the formula, that is pi by 4 is the compulsory term. If plus is there, plus, and whatever the angle, that is 2x. This formula you can use. Again you know, tan inverse tan get cancelled. What is remain? Pi by 4 plus 2x. Right? Y is equal to pi by 4 plus 2x, and dy by dx, it is nothing but the derivative of a pi by 4 0 and the derivative of a 2x, it is equal to 2. Right? This is the second unusual problem. Right? The second unusual one, isn't it? Here you have to make the conversion so that your problem, it is converted into this form, and then you can proceed. Right? On the same ground, here again I will take the third one. See, third one, every problem it is differ from each other. कुठल्याही प्रॉब्लेमचा, कुठल्याही प्रकारचा हे नाही आहे इथे. नो अगेन y इज इक्वल टू सी tan इनवर्स sec 2x plus tan 2x whole square. See, again what you have to do? Again there is no such a formula sec 2x, that is tan 2x, isn't it? Therefore what you have to do? Here again make the conversion. Sec you can write in the form of a 1 upon cos 2x, and this is sin 2x divided by cos 2x. Right? Whole square. Again if you observe this, denominator is same, directly add the numerator. 1 plus sin 2x divided by cos 2x whole square. Right? Now here don't use that formula. 1 plus sin 2x is equal to cos x plus sin x whole square, and here also don't use the formula cos square x minus sin square x. Right? So what you have to do, see here, because there is a square, if you write like this that is cos square cos x plus sin x whole square, again you will get whole square, see here, and 2 to the 4. So this formula, it is not work here. So what you have to do, see, tan inverse 1 plus sin 2x whole square, and here square of a numerator, square of a denominator, cos square 2x. This you have to write. Again 1 plus sin 2x whole square, right? And cos square theta or cos square theta you can write as a 1 minus sin square theta. Therefore cos square 2x you can write as a 1 minus sin square 2x, right? Again you can find out the factors of the denominator. 1 plus sin 2x, numerator whole square remain as it is. Here a square minus b square means a minus b, 1 minus sin 2x, and here 1 plus sin 2x, right? Again if you observe this, one bracket get cancel, see, right? And what is remain? Ek bracket cancel jala. What is remain? Again 1 plus sin 2x divided by 1 minus sin 2x. Again here you know the formula. One, it is strictly there, and whatever the term added, we want its multiplication. Therefore your problem, it is in a standard form. Now what you can write here, see here, I am containing here y is equal to this here. One, it is strictly there, and whatever the term added, we want its multiplication is there, and here that multiplication it is already there. Therefore you can write the formula like this: tan inverse 1 plus tan inverse of 2x, right? Therefore dy by dx, the derivative of a tan inverse 1, 0. Here again substitute u, tan inverse u, that is 1 upon 1 plus u square means 4x square, and the derivative of a 2x, that is equal to 2. Therefore here you have got the result 2 divided by 1 plus 4x square, right? Similarly you can do this, isn't it? Cosec 3x minus cot 3x. See the fourth one. Fourth one, y is equal to tan inverse cosec 3x minus cot 3x, right? Therefore here also you have to make the conversion. Cosec you can write in the form of a sin 3x. This is cos 3x divided by sin 3x. Again the denominator is same, directly add the numerator, tan inverse 1 minus cos 3x divided by sin 3x, right? Again you know the evergreen formula, that is 1 minus cos 3x you can write as a 2 sin square 3x by 2, and on the ground of this you have to change, don't use the triple angle, you have to make the bifurcation. What is the formula of a sin 2x? 2 sin x cos x. Here you have to write 2 sin 3x by 2 cos 3x by 2, right? This formula, this bifurcation you have to use there. Again 2 to get cancel, again 1 sin 3x by 2 get cancel. Here tan inverse sin by cos you have got as a tan 3x by 2. Again tan inverse tan get cancel, what is remain? 3x by 2. Therefore dy by dx, it is equal to 3 by 2, right? Now I am going to take the last one here, that is tan inverse root of 1 plus x square minus 1 divided by x. That is the fifth unusual, right? See the fifth unusual, y is equal to tan inverse 1 plus x square divided by x. See again if you observe this, you get confused, but there is no confusion. I have already told you that whenever in the root 1 plus x square, you can start with whatever x is equal to tan theta, right? Because 1 plus tan square theta, it is equal to sec square theta, and the out of the root you have got the sec theta. Therefore start with this, here put x is equal to sec theta, right? Therefore y is equal to tan inverse root of 1 plus sec square theta minus 1 divided by sec theta, right? Now see this problem, sorry, you have to substitute tan theta. Here again 1 plus tan square theta here tan theta. Now 1 plus tan square theta, that is equal to sec square theta, means here you have got sec theta. 1 plus tan square theta, sec square theta, and here you have got the sec theta divided by tan theta. Again make the conversion, tan inverse. Sec you can write as a 1 upon cos theta minus 1 divided by sin theta divided by cos theta. Here y is equal to tan inverse 1 minus cos theta divided by cos theta sin theta divided by cos theta. Right? Now see, cos theta get cancelled. Here again y is equal to tan inverse 1 minus cos theta divided by sin theta. Again use the evergreen formula. 1 minus cos theta you can write as a 2 sin square theta by 2, and sin theta you can write as a 2 sin theta by 2 cos theta by 2. Right? Therefore 2 get cancelled. Again 1 sin theta get cancelled. What is remain? Tan inverse sin theta by 2 cos theta by 2 you have got as a tan theta by 2. Tan inverse tan get cancelled. What is remain? Theta by 2. Y is equal to 1 by 2. And what is theta here? That is equal to tan inverse of x. Therefore the derivative dy by dx is equal to 1 upon 2 1 plus x square. Right? So here I have finished the derivative of a trigonometric function part 5. And the next session again I am going to take some unusual example that is also important in the examination point of view, that is the CET, isn't it? That examples, it is very, very important for the CET, JEE also, isn't it? So in the next session I will take the problem on what here? Inverse trigonometric function, and all the problems are again unusual. So the student, if you like my video, please share it and subscribe my channel.